Hello everybody and welcome back to another lecture in the wireless penetration testing section. Now, in the previous lectures I showed you how to capture the four-way handshake and how to brute force it with your CPU and GPU. We used two tools called Aircrack and Hashcat, and we used some of the already installed word lists basically in Kali Linux. But now let's say you want to create some of your own word lists, or you want to target a specific person that you know and you basically know something about them, and you wanted to create, for example, word lists that could help you brute force the password faster. Now, there is a simple program in Kali Linux which comes pre-installed. It is called Crunch. So let me just show you. Let me just delete the GPU as we do not need it anymore. The Crunch, let's open the manual for Crunch. It is basically a program that is used to create the word list. As we can see right here, Crunch can create a word list based on criteria you specify. The output form of Crunch can be sent to the screen, while file, or to another program, which is really important, this part right here, to another program, and I will show you why in just a second. But before we begin, let me just show you that it has a bunch of options that you basically, if you want to, you can learn. I don't know most of these options. I basically just open manual and then I specify what I want to make. Now, the simplest use of this would be to, let me just quit this, would be to, for example, type here Crunch, and the syntax would be to specify the minimal letters or numbers that you want in the word and the maximum letters or numbers that you want in the word. So, for example, let's say I want to make all the words that I basically want to make a file with the words that have 6 characters. So if I just type it like this, you will notice that it will start printing all of these words right here that are consisted from 6 characters, and it will basically go through all of the combinations there are for these 6 character words. Now that would take a long time, so let us just close this. Let me just show you before it starts once again that right here it says Crunch will now generate the following amount of data, and you can see how many bytes it will create. The size of the file would be 2000 megabytes, or basically 2 gigabytes, and the number of the basically passwords or lines that you would have in that file is this one, which is, I believe, 308 million, close to 309 million, which is a lot. It would take a lot longer, well, not a lot longer, it would take a lot of time to create this password list, and it would also take a lot of time to complete this password list in brute forcing, especially if you use Aircrack and your CPU, and also especially if you use it on a virtual machine, as we saw that the speed of Aircrack on our Kali Linux machine was only 350 passwords per second. Now imagine running that speed with this password list. It would take you months to finish. But that is just the simple use of this password list. You can also change the numbers. For example, let's say we want to make all the passwords that contain between 3 and 5 letters or characters. We can see that this is a lot smaller. It will basically print out all the passwords with 3 to 5 characters. As we can see, it really fast finished the first 3 character words and the 4 character words, and now it is on to the 5 character words, which will actually take the most of the file. Let me just see the size of it. It was 70 megabytes, and it has around 20 million passwords right here, which is basically somewhere a little less than the rocku.txt password list that we used before. Just in the rocku.txt password list, there are a bunch of passwords that were already, I believe, hacked before, and they were put in that file as the passwords that were mostly used by other users online. So those are legit passwords used at some point by some user on some website. Let's say we want to specify something else in greater detail with Crunch. So let's open manual Crunch. And let's go to some of the examples that they have right here. As we can see, example 1 crunch 1 to 8, and it gives you the explanation, which is basically crunch will display a word list that starts at A and ends at ZZZZZ, which means it will create the word list of all the words containing between 1 and 8 characters. The crunch 1 to 6, A, B, C, D, E, F, G, will create the word lists, the word list that contains words between 1 and 6 characters that only have these 7 characters right here, which is A, B, C, D, and E, F, G. Example 3 would create, let's not read all of them. Let's just go down here and see if there is anything interesting that we might need. Size file, this is not, you can also specify the size of the file, as we can see right here. The first 3 files are 20 megabytes. These are just a bunch of the options that you can specify. We do not want to actually bother with all of them. But you can specify, however, what is important to you are these characters right here. Once you specify them, let me just find where exactly are they written. They all represent here they are, with the minus thesis option that you want to know or not know, that you want to know that it exists, the minus T command, and then these 3 or 4 symbols specify pattern where the only you specify the pattern where you have for example a word in that pattern, and all the other symbols will change. As we can see, the @ symbol will insert lowercase letters. So let's say someone specified this password, they know that the God word is actually consisted in the entire password of that wireless network. So he specifies the @ will insert lowercase characters, the comma will insert uppercase characters, the percentage sign will insert numbers, and this upper arrow right here will insert symbols. Now let me show you, let's actually try that. So we press Q, and let's say we type here something like this. We want the 7 character passwords that basically have, let's say, lower letters than the word, for example, word, and then comma for the number. I believe it is a number, so let's try to see what it will print. It only has 300,000 passwords. It wasn't a word, it was only a comma. Oh yeah, I forgot to specify the minus T option, so after that you need to specify minus T option, and only then you can use this. And right now it will print all the words, as we can see right here. Now the comma was a capital letter, not a number, as we can see by the last letter right here. They are all capital. Then the first 2 are smaller characters, that went through all of the combinations. And we can see in the middle there is a word that we specified it to be there. So you can also specify, let's say, a bigger password list. So let's use the same, but right now let's use the upper arrow and another upper arrow. And here what we want to do is minus, or not minus, we want to specify 9 character word list. This will be a lot larger, as we can see, and we can see that those upper arrows represent symbols. So we said at the end there should be 2 symbols, and there really are. Now I'm not really sure why there is a 0 at the end of every, we can see right here, word 0, 0, 0. Let me just check something. Oh, it's not 0, it is, no, it is 0. I'm not really sure why is it there, but it doesn't really matter. As we can see, these are the symbols that we specify at the end, and the capital characters and the smaller letter characters. Now, the thing that you need is to write this to a file. For basically you do not want to just output it in the terminal like this. You want to write it somewhere to a file so you can use it later on. Now in order to do that, basically just type here crunch, and then for example let's say you want all the 5-letter words, and then crunch it into passwords.txt. And as you can see, it will basically put all of these, I believe 11 million or even more, yeah, around 11 million passwords into the passwords.txt file. If we cat the passwords.txt file right now, you will see all of these 5-letter passwords stored in there. So now that you did that, you can basically just run a simple aircrack -ng -w and then your password list and then the file that contains your handshake. Now I'm not really sure what happened right here. You can see it is laggy, so key not found. Did I specify something wrong? Let me just check it once again. If I run it, let me just check. I'm not really sure why isn't it outputting it right here. So let us use user share word lists common. Oh no, let's use rockq.txt. And let's see if... Okay, so right now it wants to work, not really sure. It could be because of the passwords that are only 5 letters long. It could be something like that, not really sure why, it doesn't even matter. What we will do right now is I will show you how you can use Crunch in order to pipe that into the aircrack. Now, by pipe, I mean in order to use the output of the Crunch command and use it as the input in the aircrack command. Therefore, you do not need to have any password list and you can use as many passwords as you want as long as you have time to finish it. Now, in order to do that, basically once you type a basic command which is crunch 33, this will not write all of these passwords to any file, it will only output it right here. We want to use that and pipe it to the aircrack program, so the aircrack program reads from our output right here and uses that in order to compare the hashed password. Now, how we do that? We do that simply like this. So, crunch, and let's actually try to attack my password or my Wi-Fi. We know that my password is this one. This is the password of my wireless network. And let's actually do an attack on it and pipe it. So crunch 12, since that has 12 characters, I believe. Let me just count. Yeah, it has 12 characters. Minus the option, and let's say, for example, we know that the first 4 letters, for example, yeah, let's say we only know the first 4 letters of the password, or let's say the first 6 letters, so it performs faster. So we know that this is a part of the password, and what we want to do after that is basically just specify, I believe it was this one for the smaller characters, and this one is for the numbers. Now this will run all of the combinations with 2 characters, or not 2 characters. Let me just see. Yeah, 2 smaller characters and 4 different numbers. And we want to pipe that, and to pipe it, you use this command right here, or not command, this character right here, which is the basically straight line. Upward straight line, and you type here the program where you want to pipe it. So we want to pipe it to aircrack-ng -w and then minus and then the name of your .kip file. And if you, yeah, I wanted to show you this as well. It will say please specify an SSID or BSSID. We know that the ESSID is the name of the wireless and the BSSID is the MAC address of the wireless. Now, it would be easier for us to specify the ESSID, which would be just the name of your wireless. In my case, it is this one. You specify it with -e command for the SSID, and then you just type here the name of your wireless network. Basically a simple name that you can check out on your mobile phone. Once you do that, and you have this command right here, aircrack -ng -w and then minus and space scan and then or any name of the file that you've written, and then -e, and then the name of your wireless network. And if you run this, it will give us this, it will start running it, and you can see it is basically trying all of the combinations right here. As we can see, it is using currently the first two letters, which is AA, and then it is brute forcing it with different numbers. Now, as we can see, this will take a lot longer than I thought it would take, so we will just close it right here. If I can close it. Yeah, I'm not really sure why it isn't closing. Let me just... Weird. Let me just close it like this. So we will close it once again, and then we will run it. Let me just enlarge this so you can see it better. And let's run the same command, but right now we do not want to run it with numbers. Let's say we know all of the characters that are consisted in our password, and we do not know the numbers that come after. So let's see how fast this will take. It should only brute force the number part. I believe it should have already guessed the password, but for some reason it didn't. It went through it. Let us see. We can wait for this to finish. It will take only a few more seconds, as it is already on the number 6. If it doesn't find it, I'm not really sure why it didn't find it. Let's just wait for this. Oh, we did find key, but why did it say it at the end? I'm not sure. It could possibly be that the number 0 was at the end of the list that it used. Not really sure why, but we now see that it did find the password. So our attack was successful. We were able to pipe the output of crunch command into the aircrack command and actually brute force it with this. We didn't need any password list, so for example, if you wanted to, you could use 12 character passwords. You could use it just like this and then specify it to try all of the 12 character passwords, but the problem is that this will take thousands and millions and billions of years to finish, especially with this speed right here. So it wouldn't really be smart for you to try to brute force 12 character passwords like this. But if you want to, there is an option right here. It won't work though, but it is there. So that would be about it for this crunch command. We will continue with another tool in the next lecture, where I will show you how to make a password list that could be specifically used for a single person that you might know. It doesn't have to be used only on wireless network. It can be used to brute force any account you want from that person. And we will do that in the next tutorial, and I hope I see you there. Bye! Hello everybody and welcome back, and before we finish with the wireless brute force attack, let me just show you another tool that you can use in order to create a password list specified for a single person. In the previous tutorial I showed you how to make a password list with Crunch, which comes pre-installed in Kali Linux, and right now we will use a tool that doesn't come pre-installed in Kali Linux, so we'll have to download it from the GitHub repository. Now open up your Firefox, and I believe the program is called Cupp with 2 P's, and we can download it from the GitHub. So let us just type right here Cupp GitHub. Hopefully it comes up. Let us just see right here. It is a Python program that is used, that basically just asks you a bunch of questions and then creates a password list for the answers that you specified in those questions. So here it is, cupp.py. It is this one, common user password profiler. Click on it, and we already know how to download a GitHub program, so we just copy the link and git clone it. So here it is. Let us copy this link right here. We can close this right now. Let us change our directory. Okay, we are in the root directory. Let me enlarge this and view this and zoom in. and we will git clone, then paste the name of that program .git. This will finish in a few seconds. Here it is already done. And now if we ls right here, we will have the cupp program there installed. So let us change the directory to our program, and we can see we basically get the cupp.py file and testcupp.py file. Now I believe that the testcupp.py file is basically just checking if there is anything that you need to download before you run this program. Choose the section you want to download. Now checking if, let me just see what it says right here, file will be downloaded from, okay, we want to download, oh, it is already downloading it. Okay, saving dictionary, okay, so now if we run it again, it should be all okay, or not, it should actually, not really sure why it prompts us with this, but I don't really think we need to do this. So let us just run the program itself. If we run here cupp.py, you'll see that it has some of the options available. It is not that big of a program. What we want to do right here is we want to run in the interactive mode, which is this option right here, or just -I. So interactive questions for user password profiling. So we want to do that. Let us clear the screen. So cupp.py and then -e. You will see that it won't print the options available, it will actually print some of the questions right now, and it says right here, insert the information about the victim to make a dictionary. If you don't know all the info, just hit enter when asked. So first name, let's say first name is, I don't know, John. It asks a lot of questions, so we'll just specify it right here. Let's say nickname is also John. Oh no, let's actually say Joe is a nickname. It doesn't really matter. Birth date would be day, let's say 0, then 06th, and then 1991. Partner's name, we do not know. Let's say partner's nickname, partner's birth date, we do not know. Child's name, Josh, it doesn't really matter. You can just specify all of these options if you wanted to. I will just click enter right here, so we do not waste our time in order to proceed with the password list making. Do you want to add some keywords about the victim? Let's say we want to add some of the keywords. Please enter the words. So let's say we want to enter, for example, hacker, then comma, Wi-Fi, then comma, access point. So to add special characters at the end of the words, let's say we want to add some random numbers at the end of the words. We also want to add some random numbers. Lit mode, yes, no. Let's say no right here. Now lit mode basically means it will only print out it will use the mix of words and numbers. For example, 4 is A, 1 is I, and so on and so on. And we can see that it finished making our password list, and it is saving directory to john.txt. The number of passwords is 19,000, which is not really that much. If we look at it, I'm not really sure where it saved it, save directory to john.txt. Here it is, so it is in this directory. If we cat john.txt, you will see that it used some numbers because we said to use numbers at the end. It also used the Wi-Fi name, it also used the special characters at the end, and if we scroll up, we'll see this is the date of when he was born. I believe I specified this date, or something like this. It basically just tries all of the other combinations as well. We can see the reversed John is also used right here, with a bunch of characters. Josh John as well, just Josh, and then we have the nickname, which is Joe, and then John, also with some characters and numbers. And now let me see what else do we have right here. Well, basically that would be about it. Reversed Josh, then hacker because we specified it in a word, Wi-Fi as well, and basically just a mixture of all the things that we specified in our process of making this password list. Now if you made a normal password list that you actually specified the correct information, you can now use it to attack the wireless, for example, or actually attack any other social media account or anything you want with this password list. But it is only specified for one person. So that would be about it for this tutorial. I just wanted to show you that there are programs like this that will create a password list for you. So you can use them if you need them. I don't really think we will need them in the future lectures, but it is good to know that they exist. And we will continue hacking in the next lectures, and hope I see you there, and take care. Bye. Hello everybody, and welcome back to the wireless penetration testing section. Now, in the previous videos I showed you how you can brute force the handshake with the hashcat tool and with the aircrack tool. We both use CPU and GPU in that process, and we also saw how we can create some of our own word lists in order to make our attack more possible to work. Now, the next thing that I want to show you is also a very important thing, which is how you can actually make your process of cracking even more faster than we did before. Now, you remember that we actually had only around 350 passwords per second on our Kali Linux machine with our CPU, and on my laptop we had around 4000 passwords per second with the CPU. Now, the GPU was around 100,000 passwords per second, but we can even make that faster if we wanted to, like a lot faster. So, open up your terminal. I am currently on the Kali Linux, but I will switch to my laptop when I need to show you something. But right now what I want to do is actually find our handshake that we captured. It is in the handshake folder. As we can see, it is right here, scan01.cap, and we also have a passwords.txt file. Let me just see which password list is that. It is a password list that we created with the Crunch, okay. Now, what I want to show you is basically how you can make a rainbow table out of your password list. Now, what is a rainbow table? Well, basically, rainbow tables are huge sets of pre-computed tables filled with hashed values that are pre-matched to possible plaintext passwords. Now, it allows us to crack the passwords even faster. Basically, it allows hackers to reverse the hashing function and to determine what the plaintext password might be. So, let me show you how we can actually create a rainbow table. It can take some time, so I will find on Github a password list that isn't larger than 100,000 passwords per second, so this doesn't take a long to create. Let me just open up my Firefox, and I will basically just search GitHub password list. And let's see what we can actually find on GitHub. Maybe we can find a good password list that we can use for this. You can use any password list you want. If you want to, for example, you can use the rocku.txt password list. Basically, it can be any password list you want, but it depends. The larger the password, the more time it will take to create a rainbow table. So let me just find right here password list. Let's go with the 100,000. Let's wait for this to open up. Then we will git clone this site. It has 100,000 passwords, so let us just clone this, copy, then go to our terminal in our handshake folder and type git clone and paste the file. So now that we are downloading this, it says fatal repository not found. Well, that's unfortunate, but there is another thing that we can do. We can go to the raw section right here, and it should load up the page with basically all of the passwords, and we will just select all of them. Just my Firefox is currently a little bit slow. We could have used a smaller password list if we wanted to, and basically we will if this doesn't want to copy itself, but there really isn't no point in making a rainbow table out of a password list that isn't at least 1 million passwords large. Now I'm using 100,000 passwords, so this doesn't take too long to make. Let me see what is happening with this at the moment. It is loading something, not really sure what is it loading. You know what, it basically, okay, it finished, so let us copy all of the passwords right here and let me nano pass.txt, and I will basically paste all of the passwords that I just copied. Now, since this is a virtual machine, this will probably lag out a little bit, but as soon as it finishes, we will be able to continue working with it. Well, never mind, that did lag out. I will just use a password list that I already have right here. So, or let me just create a new one with Crunch that has 8 characters at least, and let's paste it into file.txt, for example. Now, since this is 1 terabyte large, I will not really paste the entire password list. I will basically Control C soon enough. So let me just Control C right now. And basically in the file.txt we should have some passwords at least. I believe there is around 1 million passwords right here, which is more than enough. I will show you how you can create the rainbow table now with that password. So let me just delete the ones we don't need. So pass.txt.save, and we don't need passwords.txt. And let us actually rename the file.txt into passwords.txt so you don't actually get confused right here. So these are the only two things we need, a password list and the .cap file that we caught the handshake with. So the tool that we will use is called aerolib. Let's just type aerolib --help in order to see our available options. Now, as we can see right here, there are a few options. One is the SQL, the clean, the batch, verify, stats. We will use most of them, so since we need to import the password list, and we also need to import the ESSID, which is just the name of our access point. Now, in order to import the ESSID, you basically need to create a simple text file. So you just name it nano essid.txt, and what you need to do right now is basically just search your wireless access point and see what the name of it is. For my access point, it is basically this one. So I will just paste the name of my wireless access point in this file. Now I Control O, enter, and then Control C, or pardon me, Control X to exit, and you can see that in this folder, in this file, I only have the name of my wireless access point. Now that you made this, we can start using the aerolib-ng tool. So, first thing we need to do right here is basically create the rainbow table itself and import the ESSID in it. Now, how we do that? We do that with aerolib-ng. Now, after that, you specify the name of your rainbow table. You can name it anything you want. I will just name it rainbow table, or let's just do all smaller letters. And then you want to -- import, and then import SSID. And basically after this you need to specify the name of our files, which is only the ESSID. So just type here import ESSID and then the name of the file, which is essid.txt. Now once you do that, you can click here enter, and you can see it will finish relatively fast since we only imported one word. The next thing that you want to do is import the password list. Now we import the password list with the similar command, so type here aerolib-ng. Then you specify the name of your rainbow table, whatever you named it. Then you specify -- or -- import passwd, and after the passwd you need to specify the password list that you are using. In my case, that is the pass.txt. So once you do that, just click here enter, and it will read all of the passwords from the file and it will import them into the rainbow table. Now we can see right here how many passwords are there in my file. So over 1 million already. Hopefully it will stop soon. I should have Ctrl+C it a little bit earlier, so we do not have this much passwords, but it doesn't matter. This shouldn't take too long to load. The process that will take too long if you use a huge password list will be the next command, which is the -- or -- batch, since it will import and it will hash all of the private share keys or all of the passwords from plain text to hashed versions, so it can compare them faster once you run the attack. Now here we can see that we are reading over 5 million passwords, but that those are just passwords in the plain text. After that, it will compute those passwords into hashed version of those passwords. So let us see how long this will take. This is already over 7 million soon. Now it will also go, the entire process of this will also go a lot faster if you have a stronger virtual machine, or basically if you are running this on your main PC. I remember on my laptop I did the same thing a few minutes ago with the Roku.txt password list, which is around 14 million, and this process right here of importing the password list took a lot shorter time to process these lines that it reads than these 10 million passwords right here. But I will just wait for this to finish and I will get back to you as soon as it does. Well, this took a lot longer. I basically Ctrl+C this since it went over 20 million passwords. There is no need to wait for that. And you can see right now, if your importing of password list is finished, that you will have a file called rainbow table if you name it like that. Now, what you can do with this, basically you can check out the stat, which is the option in Reup. So just type here rainbow table -- stat. And here we can see there are one, and after it finishes here we can see that there is one SSID which we specified with this command right here once we imported the name of our wireless access point, and there are also 20 million passwords in the database. Now 0 out of 20 million possible combinations have been computed. So what we want to do right now is run the command called -- batch. Now that command will compute these passwords and there will no longer be 0 out of 20 million possible combinations computed. So how do we do that? Well, we run the arrowly -ng, so, and then -- batch. So once you do that, basically, or let me just add the name of the rainbow table or it won't work. So name your rainbow table, then -- batch. And when you let this run, this process will take the longest out of all of the previous processes, since it basically has to compute all the passwords in this rainbow table. Now, I will not wait for it to compute 20 million passwords, since that would take around a week time. I will basically let it compute a few passwords, or basically first 10 or 20,000 or something like that. And then after that I will Ctrl+C this program and we will run the attack with our aircrack program. If you use the smaller password list, you can wait for it to finish computing it. Basically the process of computing is dependent on your basically hardware, so as you can see right here, it computes around 10,000 passwords in 45 seconds, while as on my laptop it computes around, I believe, 100,000 passwords in 45 seconds. So, but once again, this is a virtual machine, so that is why it is so slow. If you use a smaller password list, it shouldn't take that much to finish. But after this, once it computes around 20,000 passwords, you will see how much faster the aircrack program will run compared to the previous attack that we did, where it only were able to guess around 350 keys per second. While as right now, I believe that number will grow over 2,000 or 3,000. Now we will see. Let me just, it might even be larger than that, so let us just Control C this program once it hits 25,000. So Control C right now. Let us just, not really sure why I'm not able to Control C this. Okay, here it is, we closed it. And now if we run the stats right here, it will say that 25,000 out of 20 million possible combinations have been computed, which is around 0.12%. So let me just show you that you can also, what you can also do with this tool, which is arrowlib-ng. You can basically make arrowlib. You can basically make the SQL queries to the database or to your rainbow table with the --SQL, and then you specify the SQL query you want to use. Now, we covered SQL basics, so you should know what, for example, this means. So select star from ESSID. Basically, it will select the ESSID that we imported into our rainbow table. You can also select all from passwords, but I believe that this will take a lot longer since there are a lot of passwords in our password list. Now I will Control C this, if it could. Okay, there it is. You can also select all private shared keys or basically your encrypted versions of the password with this command. So right now you can see that there are a bunch of random characters being printed out right here. Those are basically your pre-computed passwords that it hashed in the process where we run --batch. Now, after we do that, we only want to run one more command before we start the attack, which is arrowlib -ng, then the name of our rainbow table, and then --clean all. Now, this will clean all of the unnecessary things in our rainbow table and possibly make it work even faster. So I'm not really sure how long this could take. Shouldn't take too long, but we will see. Hello everybody, I had to split this tutorial since it was getting too long. Basically the last command we ran was the clean all command with the arrowlib, and now we are good to go. So now we should be able to run our rainbow table attack. Now basically let us first see once again with aircrack what did it take or what was the speed of our cracking process with the regular .cap file. So let us just specify -w and then the word list, which is pass.txt, and then scan, which is the cap file. So let us see what is the speed of this running process. Now we can see that the speed right here is around 350 keys per second. So we can see that, for example, this password list would be finished in 1 day, 4 hours and some minutes. So let us just close this right now since we won't wait 1 day. And let us see right now what is the process or what is the cracking time of our rainbow table that we created in the previous video. So let's just let this aircrack quit right here, since it is not giving us our command tool. Okay, here it is. And now let's actually run our attack with aircrack with the rainbow table. So how we do that? Basically just type here aircrack -ng, then -r for the rainbow table, and then specify the name of your rainbow table, which in my case it is just rainbow table. So I type it right here, and then you need to specify the .cap file that you have your handshake in, which is scan.cap. And once you do that, if you click here enter, you can see that it already finished and that the speed of the password cracking is now 44,000 keys per second. Now it finished this fast because we only computed around 20 to 25,000 passwords in our rainbow table, so it basically finished in less than a second or in half a second. So you can see that the speed process of cracking this is basically around 100 to 150 times larger than the previous cracking process. Now, if you use a rainbow table with the GPU, which is even faster, you can go over 1 million passwords per second. let me just show you the same process with the air crack on my laptop, so you can see how fast it cracks there. So here we are on my laptop, and I already created the rainbow table right here with the rock.txt password list. I basically computed around 600,000 passwords right here, so we don't have to wait and do this process all over again. I also have the same scan.cap file from our Kali Linux machine, and also the same ESSID file, which only has the name of our wireless access point. Now let's run the basically air crack tool once again. So let me just become a root and let me enlarge this so you can see it a little bit better. There we go. So right now what we want to do is basically, let me just first show you the air crack cracking time with the rocky.txt regular password list. So we just type here -v and then specify the path to the rocky.txt. So once we specify that, all we need to specify also is the scan.cap file, and we can let this crack, and you can see that on my laptop the current cracking speed is basically 300 or 3300 passwords per second. Now if I also plugged in my power cable, it would go over 4000 passwords per second. But let us see what is the speed of the cracking process with a rainbow table right here. So as I said, right here I have a rainbow table that I computed for around 600,000 passwords. So let us run the same process right with the same cap file right now. So -r, and then we specify the name of the rainbow table, and then we specify the name of our .cap file. And let this run, and you can see that the speed of the cracking process is over 200,000 keys per second, and that is the speed with the CPU. So you can see that it finished around 600,000 keys per second in only 2 seconds. So you can see how fast this can go. This basically can finish a 10 million password list in a matter of seconds. So imagine now you had a password list with over 1 billion passwords. That would take a reasonable amount of time. It would basically take, I believe, maybe 2 hours only, which is not that long for 1 billion passwords. So this is really useful once you have a huge password list that you want to use, since if we, for example, ran only a normal attack without the rainbow table, this would take a lot longer to finish. So I only wanted to show you that, so that would be about it for the rainbow tables. I hope you enjoyed it, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back. Now, before we continue to the next section, I just want to show you a simple tool that you can download from Github, which you can use in order to automate the process of creating the evil twin access point. Now, what I mean by that is basically there is a tool on GitHub that will do all of the stuff that we will manually do later on automatically. So it will create all the files it needs and all the process of configurations in order to create the evil twin, or the basically another access point for you. Now that this can be used once you need an access point with a login page, so you can prompt users to enter their credentials in order to access the internet, and you can capture those credentials basically with Wireshark on any sniffing program. Now I will not cover how to use this tool, since my Kali Linux, as I said, can't support the evil twin attack. I will only show you how to install it, but the process of using that program is relatively simple. You just need to click on some of the numbers in order to make that work. So let us just open up our Firefox. Let us go onto the new tab and search for the Fluxion. So just type here Fluxion, GitHub. Once you open that, go onto the first link, which is the Wi-Fi Analyzer Fluxion official repo for Fluxion. Click on it. And what you want to do is basically do the process of installing a GitHub program. So copy the link of the file or all of the program, and then type here, let me just go one directory back into our root directory, and then git clone, and then paste the link and add .git. Now this will take a few seconds to download, and once it is downloaded, I will show you how you can install all of the required things you need in order to run that program. Now after that, you can run the program and it will basically just give you a bunch of the options available for the program, and you just click on the number which suits your needs. It is very simple to use, so we will not cover the entire program, mostly because I can't really run it on my Kali Linux environment. So let me just see, there we have the folder Fluxion, so change your directory to it. And once you do that, you can list the files that it has in that directory, and you can see there is a program called fluxion.sh. Now before we run this program, we need to perform the process of installation, which we can find in the install subdirectory of our Fluxion directory. So just change directory to install, list all the files, and you will see a file called install.sh. Now in order to run this file, we need to type here bash and then install, and then basically just bash install.sh. Now once we run that, it will basically download all the needed files that we need in order to run this program. As we can see, I haven't updated my Kali Linux for a long time, so this might take actually longer than it should for you if you updated it regularly, since we can see there are a bunch of packets that need to be removed and that are no longer required. Now it is removing those packets and it will install the packets it needs in order to run this. So we just wait for this to finish, and once this finishes, we can basically run the fluxion.sh if we successfully installed all of the files it needs in order to run it. So right now it's removing some of the Python files right here. Basically I believe those are the outdated versions, and it will basically install the newer versions after it removes all of these older ones. So we will wait for this to finish. So here it is, the process of installation of Fluxion has finished for me. As we can see right here, it had to install several things in order to make this program work. Now, it probably took a lot faster for you to finish this, since I had a bunch of packets that should have been installed on my Kali Linux machine. But once this finishes, you're basically good to go, and we can just see the back one directory. Let me just clear the screen and type ls once again. And all you need to do right now is basically run the fluxion.sh. So we do that with bash fluxion.sh, and you can see that it will perform a checklist of all the programs that it has to have in order to create the program. Now we saw that all the programs were already installed with the OK mark, and now right now the first question it asks right here is select your language. So you select any language you want. And for me, right now, it will not be able to proceed since it says there are no wireless cards. Now, for you, if you have a wireless card, you can just follow the simple steps that this program takes in order to create a fake access point with the captive portal. Basically, it automates the entire process. You do not need to do anything else except choose for the wireless access point, and you will be good to go. We will do this manual process. We'll do this process manually later on, probably somewhere towards the advanced section, but for now on, I just want to show you that this tool exists and you can use it if you want to, or basically if your wireless card supports it. That would be it for this tutorial. I would have covered the entire program if my wireless card supported it, but it doesn't, so we will just continue with the manual process later on. But in the next lectures we will cover some of the security measures you can take in order to protect your wireless network, and we can also check out how we can, for example, find the name and connect to the hidden networks if someone has set their wireless access point to be hidden. I will show you that in the next lectures, and I hope you enjoyed these ones for now on, and hope I see you in the next one, and take care. Bye.